Welcome to this deep dive where we really try to pull out the essential knowledge from different sources just for you.
Yeah, boiling it down.
Exactly. Today, we're tackling something a lot of people encounter, the GED Mathematical Reasoning Test.
Mm.
We've got a GED test prep guide here, and our mission really is simple. Distill what you absolutely need to know about this exam.
So you can get the core of it without getting bogged down.
Precisely. Think of it as your express route to understanding the GED math test. What's on it, how it works.
And maybe some surprising bits, too.
No.
Stuff that might be useful even if you're not taking it, but maybe supporting someone who is, or just curious about these tests.
Absolutely. So let's dive right in. What's the first thing that jumps out about this test from the guide?
Well, I think it's the sheer breadth of mathematical thinking it tries to assess. It's not just, can you remember a formula?
Right. It's about applying things.
Exactly.
Yeah.
Applying those foundational skills across different mathematical areas.
Okay, so let's start with the basics, the structure. If you're sitting down for this test, what's the format like?
Okay, so you're looking at 46 questions in total. And there's a really interesting split with the calculator.
Oh, how so?
Only 5 questions are in a specific no calculator section, really testing those fundamental arithmetic skills.
Just 5.
Yeah.
Okay.
Then the other 41 questions, the vast majority, you can use a calculator.
That's good to know. And how long do you get for all 46?
You get 115 minutes for the whole thing.
Okay, so almost 2 hours. That feels like a decent amount of time. And are the questions all like multiple choice? Pick A, B, C, do.
No, not entirely. That's probably the main type, multiple choice, but they mix it up.
Ah,
You'll also see fill-in-the-blank Dropbox type questions where you select from a list,
okay.
drag and drop items,
Yeah.
and even some where you have to click on or select an area in a graph or diagram.
Interesting. So it sounds like they're testing understanding in a few different ways, not just recognition.
That seems to be the goal, yeah. A
Yeah.
more comprehensive check of your comprehension.
Now, a big worry for math tests is always formulas. Do you have to memorize every single one?
That's actually some good news. The test provides a reference section, like a formula sheet, with the essential ones.
Oh, fantastic.
Yeah, so you don't need to have, say, the volume of a cone memorized cold. You need to know when and how to use it, which is just the focus,
To application, not just recall. Makes sense.
And another important point the guide emphasizes, there's no advanced math, no trigonometry, no calculus.
Okay, that definitely narrows the scope. That's reassuring for a lot of people, I bet.
For sure.
And it sounds like doing well isn't just about passing. There are potentially other benefits.
Absolutely. Passing gets you the high school equivalency, obviously. But depending on your score, you might also get a college-ready designation.
College ready. Okay.
Yeah, and even potentially, this is significant, earn up to 10 college credit hours.
Wow, 10 credits.
Yeah, though that depends on your score and the specific college's policies, of course. But it's a potential big head start.
That really does raise the stakes, or rather the potential rewards. Okay, so let's dig into the actual math content. What are the main subject areas?
The guide breaks it down pretty clearly. It's roughly 45% focused on arithmetic and geometry concepts.
Okay, almost half.
And the other 55% is algebraic reasoning and data interpretation.
So a slight edge towards algebra and data.
Seems like it. That 55% suggests those areas are maybe a bit more heavily weighted in terms of what they want to assess. It gives you a clue where to focus your energy.
Good point. Okay, let's start with that 45% chunk, then arithmetic and foundational math. Where does the guide begin?
Right at the beginning, with the real number system, understanding the different kinds of numbers.
Yeah.
Well, you start with counting numbers, 1, 2, 3, then whole numbers, which just adds 0.
Right.
Then integers, which brings in the negatives. So positive, negative, and 0. These are sort of the building blocks.
First numbers we learn, basically. What comes next in this system?
After integers, you get rational numbers. These are numbers you can write as a fraction or as decimals. They either stop,
Yeah.
terminate, like 0.5,
Okay.
or they repeat in a pattern, like 0.333.
Right, like 1/3.
Exactly. And then you have the other kind, irrational numbers.
Ah, like pi.
Pi is the classic example. Or the square root of 2 or square root of 7. Decimals that go on forever without repeating.
Got it. So it's about knowing these categories exist and how they fit together, like all integers are also rational numbers.
Precisely. Because you can write any integer as itself over 1, understanding that hierarchy is fundamental.
Okay, so once we know the types of numbers, the next thing is what we do with them, right? Operations.
You got it. The 4 basics. Addition, subtraction, multiplication, division. Sum, difference, product, quotient.
Standard stuff.
Yeah, and you'll see problems written horizontally or vertically. But the key thing here, remember those 41 questions?
With the calculator allowed.
Exactly. For most of the test, you'll have an online calculator for these operations. So it's less about, long division by hand
Yeah.
and more about knowing when to add or multiply or whatever in a problem
Yeah.
and how to use the calculator effectively.
That online calculator sounds like something you'd want to practice with beforehand.
Definitely. Get familiar with its functions.
What about other basic concepts? Absolute value comes up.
Absolute value is pretty straightforward. It's just how far a number is from zero. Distance.
So it's always positive or zero.
Always non-negative, yeah. The absolute value of 7 is 7. The absolute value of -7 is also 7. Just the size, ignore the sign.
Clear. Now, sign numbers. Adding and subtracting positives and negatives. That can trip people up sometimes.
It can. The rules depend on whether the signs are the same or different when adding or subtracting.
Okay.
But for multiplication and division, there's a simpler rule of thumb. Count the negative signs. An even number of negatives, positive result. An odd number of negatives, negative result. The guide has examples like -12 times -13 is positive 1 in 56.
2 negatives, even number, positive answer. Makes sense.
But -5 times -6 times -11. That's 3 negatives.
Odd number.
So the answer is negative. -330 in this case. Same logic for division.
That even-odd rule is a great shortcut. Okay, exponents. Another area with specific rules.
You need the basics. The base number and the exponent telling you how many times to multiply the base by itself.
Like 2 to the power of 3, 2 is the base, 3 is the exponent.
Exactly. And the key properties for the GED are multiplying powers to the same base, you add the exponents.
Okay.
Raising a power to another power, you multiply the exponent.
Right.
And dividing powers with the same base, you subtract the exponents. Knowing these lets you simplify things fast.
Saves a lot of number crunching. Now, if you have multiple operations in one expression, order matters, right?
Absolutely critical. That's the order of operations, usually remembered by PEMDAS.
Parentheses, exponents.
So multiplication and division next, working left to right.
Okay, they're paired.
Right. And finally, addition and subtraction, also working left to right. Following PEMDAS ensures you get the one correct answer.
A cornerstone of math, really. What about handling really big or small numbers, scientific notation?
Yeah, that's its purpose. A way to write huge or tiny numbers using powers of 10, like a number between 1 and 10 times 10 raised to some power.
So 453.7 becomes 4.537 times 10 to the second power.
Exactly. You move the decimal 2 places left,
Right.
and a tiny number like 0.00398.
Would be 3.98 times 10 to the minus 3. Moved it right 3 places.
Perfect. It makes those numbers much easier to work with and compare.
Definitely useful. Okay, let's shift to fractions. Always a popular topic. What's key for the GED?
Need to know the parts. Numerator on top, denominator on bottom. For adding and subtracting, the big deal is common denominators.
Gotta have them if they're different to start with.
Right. If they're the same, you just work with the numerators. If not, you find a common one first. Multiplication is simpler.
Just multiply straight across, tops and bottoms.
Yep. Numerators together, denominators together, and division that involves the reciprocal.
Ah, the invert and multiply rule. Flip the second fraction and then multiply.
That's the one. Understanding reciprocals is part of it.
Now, related to fractions are mixed numbers and improper fractions.
Right. A mixed number is like 7 and 23. Whole number and a fraction part.
And improper is when the top is bigger than the bottom, like 233.
Exactly. You need to be able to convert back and forth between them pretty comfortably.
Why is that important?
Sometimes it's easier to do calculations, especially multiplication or division, if everything's an improper fraction first.
Ah, okay. And I think you mentioned the calculator helps with fractions too.
Yes, the TI-30XS online calculator they provide has functions specifically for handling fractions, which can be a huge help.
Good to know. Okay, decimals. What's the focus there?
Understanding place value is key, usually up to the 10,000th place according to the guide, and rounding rules how to round a decimal correctly.
Makes sense.
And then, again, the 4 basic operations: adding, subtracting, multiplying, dividing decimals. The main thing is keeping track of that decimal point.
Always the tricky part with multiplication and division.
Careful placement is everything.
And how do fractions and decimals connect on the test? Do you need to convert?
Yes, you need to know how to turn a fraction into a decimal.
Which is just division, numerator divided by denominator.
Exactly. Like 7 divided by 20 gives you 0.35. Simple division. The calculator helps here too, especially if it's a long or repeating decimal.
Right. Okay, we've hit quite a bit. Numbers, operations, fractions, decimals. The last piece in this foundational section seems to be percents.
Correct. Percent just means out of 100,
Uh,
right? So 37% is 37 out of 100.
or 0.37 as a decimal.
Precisely. You need to be able to convert between percents and decimals easily. And crucially, calculate a percentage of a number.
Where of usually means multiply, like 75% of 284.
You got it. 0.75 times 284. That kind of calculation is very common.
And the last bit listed here is simple interest. Seems a bit specific.
It's a practical application. Basic financial literacy. You need the formula. I is part.
Interest equals principal times rate times time.
Yep. P is the starting money. R is the annual interest rate as a decimal. T is time in years. You should be able to plug in values and find the interest earned or the final balance.
Okay, I part. Got it. So that wraps up the arithmetic and foundations. It's quite a lot of ground, actually.
It is. It sets the stage for the other big chunk. Algebra and data interpretation, that 55%.
Right. Let's transition there. Where does the algebra part start?
With the language, basically. Defining the terms.
Like variable, coefficient?
Exactly. Variable is the letter, like x. Coefficient is the number multiplying it, even if it's an invisible one.
Right, like in x, the coefficient is 1.
Term is a combination, like 3x or 5. Expression or polynomial is a string of terms added or subtracted.
Okay.
Like terms are terms you can combine, like 2x and 5x. And an equation is when you set two expressions equal to each other with an equal sign. Getting that vocabulary down is step one.
Makes sense. You need the words before you can do the grammar, so to speak. So after definitions, solving equations.
That's the core skill. Starting with simple ones like 3x plus 2 equals 11. You need to isolate the variable, x in this case.
Using opposite operations on both sides. Subtract 2, then divide by 3.
Precisely. Keep it balanced. Then you move to multi-step equations, maybe with variables on both sides that need a few more steps.
Okay.
And sometimes equations have more than one variable, and the goal isn't to find a number, but to solve for one variable in terms of the others, like rearranging a formula.
Isolating y in terms of x, for example.
Exactly. Manipulating those relationships.
And algebra isn't just symbols, right? The guide mentions word problems.
A big part of it, yeah. Translating a real-world situation into an algebraic equation and then solving it.
Taking the story and turning it into math.
Right. Identifying what's unknown, that's your variable, figuring out the relationships described, setting up the equation, and finding the answer.
Okay. Now, besides equations, there are inequalities. How are they different?
Inequalities use symbols like greater than, less than, greater than or equal to, less than or equal to. They compare values instead of saying they're strictly equal.
So looking for a range of answers sometimes.
Often, yes. You need to know what those symbols mean and the key words and word problems that signal them, like at least or no more than.
And solving them is like solving equations, mostly.
Mostly. Same steps, but with one huge rule to remember.
Which is?
If you multiply or divide both sides of the inequality by a negative number, you must flip the inequality sign. Less than becomes greater than and vice versa.
That's the crucial difference. Easy to forget.
Very easy. Got to watch out for it.
Inequalities show up in word problems, too.
Definitely. Scenarios where you're finding a maximum number of items you can buy or a minimum score needed, things like that often translate to inequalities.
And visually, how do you represent inequality solutions?
On a number line. You use an open circle for or because the endpoint isn't included, and a closed, filled-in circle for A or O because the endpoint is included. Then you shade the part of the line that represents all the possible solutions.
What if you have two inequalities together? Like x is greater than -5, a and d less than or equal to 3.
That's a compound inequality. You need to understand how to graph those two, showing the segment on the number line that satisfies both conditions. Or sometimes it's an or condition.
Okay. Let's talk squares and square roots. What's needed there?
It helps to know your perfect squares, maybe up to 15 squared, and the guide also mentions squares of tens, like 20 squared, 30 squared.
Okay, some memorization helps.
And understanding what a square root is, the number that multiplies by itself to give the original number. You should know the roots of perfect squares up to 144 without a calculator.
Like square root of 81 is 9.
Exactly. For non-perfect squares, like the square root of 11, you'd use the calculator to get an approximation.
And operations. Adding square roots.
You can only add or subtract them if the number under the radical sign, the radicand, is the same. Like 2 under 3 plus 5 over 3 is 7 here. Multiplication and division have different rules.
Got it. What about cubes and cube roots? Similar idea.
Very similar. No, the basic cubes, it'd be 1 through 6 and 10, and their roots.
Okay.
The key difference, you can take the cube root of a negative number. The cube root of -8 is -2 because -2 times a -2 times -2 is -8.
Ah, unlike square roots of negatives in real numbers. Good distinction. Now, ratios and proportions seem like big problem-solving tools.
They are. A ratio compares two quantities written as 3 to 5, 3.5, or the fraction 35.
Okay.
A proportion is just two ratios set equal to each other. You use proportions to solve for unknowns when things scale up or down, like adjusting a recipe or reading a map scale.
Setting up that equality and cross-multiplying often works.
That's a common way to solve them, yeah.
And how do percents tie into proportions?
A percent is a ratio out of 100, so you can use the proportion formula. N100 expands part. You can plug in the numbers you know the part, the base, whole, or the percent n, and set up that proportion to find whichever piece is missing. It's a really useful structure for percent problems.
Nice. Okay, we've covered a lot of algebra mechanics. Let's connect it to graphs, linear equations, and the coordinate plane.
Right. Need to know the basics, x-axis, y-axis, the origin, 0, 0, 0, how to plot points using coordinates, x, y.
Standard graph paper stuff.
Yeah. Then the idea of relation, any set of points, and a function.
What makes a relation a function again?
Each input, x value, has exactly one output, y value. Can't have one x go to two different y's. Think of the vertical line test on a graph.
Right. And domain and range?
Domain is the set of all possible input values, x's. Range is the set of all possible output values.
Not y's. Okay. And for straight lines on this plane, slope and intercepts.
Crucial concepts. Slope is the steepness, rise over run, the change in y over the change in x.
Positive slope goes uphill left to right, negative goes downhill.
Exactly. Slope of 0 is a flat, horizontal line. And a vertical line has an undefined slope.
Can't divide by 0 in the run.
Right. And the y-intercept is just where the line crosses the y-axis. The b value in y is mx plus b.
Speaking of which, different forms for the equation of a line.
Yep. Three main ones mentioned. Slope-intercept form, y mx plus b, is great because you instantly see the slope m and y-intercept b, easy to graph from.
Most common one, probably.
Then there's point-slope form, y m x 0. Useful if you know the slope m and just one point x0 on the line.
Lets you build the equation directly.
And standard form, x plus by c. Sometimes useful for finding both intercepts quickly or just representing the relationship. You should be comfortable converting between these forms.
Okay. What about inequalities on the coordinate plane? Not just lines, but shaded areas.
Right. For linear inequalities like y 2x plus 1, you first graph the line y equal to x plus 1.
Dash line or solid line?
Dash if it's error because the line itself isn't included. Solid if it's error.
Then the shading.
Pick a test point, not on the line, like 0, 0, 0 if possible. Plug it into the inequality. If it's true, shade the side with a test point. If false, shade the other side. That whole shaded region is the solution set.
Got it. And if you have two lines graphed together, systems of equations.
Yeah, a system is just two or more equations considered together. The solution is the point, or points, where their graphs intersect. That's the graphical method of solving.
Where they cross is the XY that works for both. What if they don't cross?
Parallel lines, no solution. If they're the same line, infinitely many solutions.
And algebraically, besides graphing.
Two main methods. Substitution, solve one equation for, say, y, then substitute that expression into the other equation, and elimination. Add or subtract the equation strategically to make one variable cancel out.
3 ways to solve systems.
Right.
Graphing, substitution, elimination. Okay. Now, moving beyond lines, quadratic equations.
Yep, equations with an x squared term. Standard form is xy plus bx plus c equals 0. Their graphs are parabolas, those U-shapes.
And solving them, finding the x values.
Several ways. Factoring is one, try to break the quadratic into two linear factors, like x plus 2 by 3, I go 3, easel way. Then set each factor to 0.
So x equal x2 or x equals 3.
Right. If it doesn't factor easily, there's the quadratic formula. Big formula, but it always works. It's usually on the formula sheet.
That's handy.
And completing the square is another method, sometimes used to find the vertex of the parabola easily. The vertex is the minimum or maximum point.
Okay, quadratics covered. Last algebra bit. Rational expressions. Sounds like fractions with algebra.
That's exactly what they are. Fractions with polynomials in the numerator or denominator.
Then you need to multiply and divide them.
Yeah. Multiplying is like fractions. Multiply tops, multiply bottoms, then simplify by factoring everything and canceling common factors.
Okay.
Dividing is also like fractions. Flip the second one reciprocal and multiply, then factor and cancel again. Factoring is key for simplifying these.
Makes sense. Factor first. Okay, that's a hefty chunk of algebra. Let's switch gears to measurement and geometry. Starts with units.
Yeah, need to be familiar with both North American units, inches, feet, miles, pounds, tons, cups, gallons, etc., and the metric system, meters, kilometers, grams, kilograms, liters.
And converting between them, or just within each system?
Mostly converting within each system using given conversion factors, like inches to feet or milliliters to liters.
Okay. Basic geometric ideas. Points, lines, planes.
Definitions, yeah. Point is a location, line extends forever, plane is a flat surface, colony or points are points on the same line.
And angles.
Types of angles. Acute, less 90 degrees, right, exactly 90 degrees. Obtuse, more than 90 degrees. Straight, 180 degrees. Also pairs. Complementary, add to 90 degrees. Supplementary, add to 180 degrees.
Got it. Lines interacting. Parallel and perpendicular.
Yep. Perpendicular lines meet at a right angle. Parallel lines never meet, same slope. And when a third line, a transversal, crosses parallel lines.
You get all those angle relationships.
Exactly. Vertical angles are equal, corresponding angles are equal, alternate interior are equal, alternate exterior are equal. Knowing these helps find unknown angles.
Useful shortcuts. Okay. Shapes. Quadrilaterals. Four-sided ones.
Know the family. Trapezoid, one pair parallel sides, parallelogram, two pairs parallel sides, opposite sides equal. Rhombus, parallelogram with equal sides. Rectangle, parallelogram with right angles. Square, rectangle with equal sides, so it's everything. Know their properties.
Square is the VIP quadrilateral. What about circles?
Key terms. Radius, center to edge. Diameter, cross through center, twice the radius. Circumference, distance around. Arc, part of the circumference. And the formula C, or C is 2r.
Pi times diameter. Got it. And triangles. Three sides.
Classify by sides. Equilateral, all equal. Isosceles, two equal. Scalene, none equal. And by angles. Acute angles, right? One right angle. Obtuse, one obtuse angle.
Two ways to classify them. What about similar triangles?
Similar triangles have the same shape. Corresponding angles are equal and corresponding sides are proportional. Really useful for finding unknown side lengths.
Setting up a proportion again. And the big one for right triangles.
Pythagorean theorem. A plus B equals Theos, where C is the hypotenuse, the side opposite the right angle. Tangential.
Absolutely.
Yeah.
Now, measuring 2D shapes, perimeter and area.
Perimeter is the distance around the outside. Area is the space inside. You need the formulas for basic shapes.
Yeah.
Square, rectangle, triangle, circle, circumference is a perimeter, parallelogram, trapezoid. The formula sheet helps here.
Need to know which formula goes with which shape. And for 3D figures.
Surface area and volume. Surface area is the total area of all the outside surfaces. Volume is the space the figure occupies.
Like how much paint to cover it versus how much water it holds.
Good analogy. Again, need the formulas for cube, rectangular prism, a box, cylinder, cone, period, sphere. Formula sheet is your friend.
And sometimes you use these formulas with algebra.
Yes, the guide mentions problems where you might know the area of a rectangle and its length, and you use the area formula gave the WN to solve for the width, W. Or similar problems with volume or surface area.
Applying algebra back into geometry.
Yes.
Okay, that covers geometry. Final big section. Data analysis. What's involved?
Interpreting data presented visually. Tables, pie charts, bar charts, line graphs, pulling out information, seeing trends.
Reading the story the data tells.
Exactly. And calculating summary statistics.
Measures of central tendency.
Right. I mean, the average, median, the middle value in order, mode, most frequent value. Also range, difference between highest and lowest. Need to know how to find each one.
Median, mode, range, standard data descriptors. What about probability? Chances of things happening.
Basic probability, yeah. It's the ratio. Number of desired outcomes divided by the total number of possible outcomes, expressed as a fraction, decimal, or percent.
Like pulling a red sock from a drawer.
Classic example.
And more advanced counting. Combinations, permutations.
Some basics. The counting principle. If you have several choices to make, multiply the number of options for each choice to get the total possibilities.
Like outfits from shirts, pants, shoes.
Yep. Factorials like 6 by 4 by 4 by 3 by 2 by 1 come up. And then combinations. Order doesn't matter, like choosing a committee. And permutations. Order does matter, like finishing first, second, third.
And the calculator might help with combinations, NCR, and permutations, NPR.
Usually, yes. There are formulas, but the calculator functions are much faster if available.
Good tip. What about sequences of numbers, series?
Recognizing arithmetic series, add the same number each time, and geometric series, multiply by the same number each time. Maybe finding the next term or a specific term in the sequence.
Identifying the pattern, and lastly here, mathematical models. What does that mean?
Using functions, often written as fx, to represent real-world scenarios.
Like fx equals 2x plus 3.
Yeah. You need to be able to evaluate them, like find f5 by plugging in 5 for x. And particularly, use linear functions, fx, mx plus b, to model situations with a constant rate.
like a plumber charging a flat fee plus an hourly rate.
Perfect example. You might need to create the function, understand what the slope m, hourly rate, and intercept b, flat fee, mean in context, and use the function or its graph to answer questions.
Connecting the algebra back to real life again. Okay, that covers the major content areas. Before we wrap up, how is this test actually scored?
It's scored on a scale from 100 to 200 points.
Okay. What's passing?
Below 145 is not passing. 145 to 164 is passing, that gets you the high school equivalency.
And higher score.
165 to 174 is passing and gets that college-ready designation we talked about.
Right.
And then 175 to 200 is top tier. Passing, college-ready, and potentially qualifies you for those college credits up to 3, the guide says, for this score range.
Okay, so clear score bands with increasing benefits. That's helpful context. So bringing this all home, this deep dive really shows the GED math test is, well, it's pretty comprehensive.
It really is. It spans quite a range, doesn't it?
Mm.
From basic number sense and arithmetic right through foundational algebra, geometry concepts, and interpreting data. It covers a lot of ground.
Yeah. And for you listening, maybe a key takeaway is that it seems to be less about pure calculation, especially with a calculator available for most parts, and more about understanding the concepts and how to apply them, knowing which tool to use when, so to speak, and definitely being comfortable with those different question types.
Absolutely. And maybe that leaves you with something interesting to think about. Looking back at all these topics we've touched on, number systems, equations, inequalities, slopes, shapes, probability, which of these areas do you find most interesting? Or maybe which ones feel like the biggest hurdle? Thinking about that and perhaps exploring those specific areas a bit more could be really beneficial, whether it's for your own growth, helping someone else out, or just satisfying your own curiosity about how we measure mathematical reasoning these days.